Okay, something happened here. So when I was recording page 3, the program that does the recording locked up, and I don't have anything recorded. So I'm not going to rework the problem. I'm going to describe how to rework it. So this one says graph the function, find its inverse, then graph the inverse. So the first thing I'm going to do is my function is f of x equals 2 times x squared, but I'm only going to use the x values that are less than or equal to 0. Because remember, if I graph this whole parabola, what's going to happen is that the inverse would not be a function. So I have to specify 1/2 the parabola, so I'm specifying it where the x is less than or equal to 0. So I've got y equals 2x squared, and I'm picking some x values. So I pick an x, and they have to be negative, so there's my values for x, and there's my values for y I got by plugging the x values into the equation. All right, so 0, 0, there, -1, 2, -2, 8, -3, 18. So there is my function graph. And then I'm going to take the inverse of that. So if I set y equals to 2x squared, then I switch the x and the y, I get y equals 2y squared. Get the 2 out of there, I divide by 2. X over 2 is equal to y squared. Then I take the square root of both sides. Okay, now notice I put a negative out there. Why did I do that? Well, because remember, like I said before, this is a parabola, but I'm only using the left-hand side of it. So what that's going to become when I take its inverse is it's only going to give me the bottom of the parabola on the inverse. That would be the reflection part. This part up here, that would be the x over 2, but I want the part that's below that. So because I specified the domain at the start, was going to be x, would be these values on the left-hand side of the parabola. Okay, so, and you can see that's going to be true when I end up taking and I end up actually graphing the equation. I'm going to simply just switch my x and y values for the inverse. So here's my inverse, negative of the square root of x over 2. And I'm going to take my x value, make it a y, take my y value, make it an x. So -1, 2 becomes 2, -1. -2, 8 becomes 8, -2. And when I plot that, sure enough, it becomes the part that is below the x-axis. And we know from our knowledge of square roots that is a negative of the square root of x over 2. So I definitely need that negative sign out there. Okay, so let's go ahead and work these out. Now what I have here is I have a radical, it's a square root, and I need to isolate that radical. So I'm going to divide both sides by a -4, and that's going to get me a 52 divided by 4 would be 13. So, and now I'm going to square both sides. So I have b minus 3 squared is equal to 13 squared. That would give me b minus 3 is equal to 169. I want to make sure this is running. Okay, so anyway, continuing, I've got b would be equal to, add 3 to both sides, 172. So we need to check that. So I'm going to check my answer. So a -4, times the square root of 172 minus 3 is that equal to a -52. -4 times the square root of 169 is that equal to -52. -4 times 13 is that equal to -52. -52 is equal to a -52. Yeah, that's a good answer, so we'll circle it. Move to the next one. I'm going to square both sides. So I don't have any numbers to worry about in the squaring, so I'm simply going to take this side, square it, this side, square it, and that's going to give me 3x minus 5 is equal to 2x. So let's subtract 2x from both sides. So that's going to give me x minus 5 equal to 0. Now I'm going to add 5 to both sides, so I have x is equal to 5. Okay, I'm going to check that. So I've got the square root of 3 times 5 minus 5. Is that equal to the square root of 2 times 5? So over here, I'm going to have 15 minus 5. Is that equal to the square root of 10? Square root of 10 equal to the square root of 10. Yeah, that checks, so x equal to 5 is a good answer. Now let's do the next one. The radical is already on a side by itself. It's already isolated, so I'm ready to square both sides. So I'm going to square this side, square this side. So what I'm going to have is n squared is equal to 40 minus 6n. Now to solve a quadratic, I'm going to get 0 on one side and all the other terms on the other. So I would have n squared minus 6n plus 6n minus 40 equal to 0. So let's see if we can factor it. Two numbers that multiply to negative 40 but add to 6. Well, how about n plus 10? N minus 4 equal to 0. So I have n is equal to negative 10. N is equal to 4. Let's check that. So let's check negative 10. So I'm going to have, plugging that in, I have a negative 10 is equal to the square root of 40 minus 6 times a negative 10. So I have a negative 10 is equal to the square root of 40 plus 60. Have a negative 10 is equal to the square root of 100. Negative 10 is equal to 10. No, that's not true. And really, basically, when I saw the square root over here all alone and a negative number on this side, I know right then that it wasn't going to be a good solution. So this is extraneous. Let's go to the check the n equal to 4. So I'm going to have 4 is equal to the square root of 40 minus 6 times 4. 4 is equal to the square root of 40 minus 24. 4 is equal to the square root of 16. 4 is equal to 4. Yeah, that checks. So 4 is a good solution. Okay, the next problem. Well, the radical is isolated over here, so I don't have to add or subtract anything. What I need to do is square both sides. Now, squaring x minus 3, you do not distribute the exponent in. That's x minus 3 times x minus 3. So this is going to be 6 minus 2x is equal to x squared minus 6x plus 9. Once again, we need to get 0 on one side and all the terms on the other because it's a quadratic. So if I add 2x to both sides, I've got x squared minus 4x. And now I'm going to subtract the 6 from both sides, and that's going to give me 3 on the other side. So let's see if I can factor it. I would have x minus 3, x minus 1. So I can have x equal to 3, x equal to 1. Let's see if those work. So I'm going to check 3. So I've got the square root of 6 minus 2 times 3 is equal to 3 minus 3. The square root of 6 minus 6 is equal to 0. The square root of 0 is equal to 0. 0 equal to 0. That's true. That's a good solution. Let's try the other one. Checking 1. Okay, so I've got the square root of 6 minus 2 times 1 is equal to 1 minus 3. The square root of 6 minus 2, that's going to be the square root of 4, is equal to a negative 2. Well, right now, I already know it's not going to work because I have a square root equaling a negative number. So 2 is equal to a negative 2. That's no. So this is extraneous. Moving to the next one. Okay, so well, we'll get there. All right. So I need, look, this radical is already isolated. So I'm ready to square both sides. Oh, but I got this negative 1 over here. There's nothing I can do with that negative 1. This radical is already isolated, so I just have to square both sides. So that's what I have to do. And that's going to create a mess, because what I have is this is really this. This is really the square root of 8r plus 1 minus 1 times itself, because it's squared. And that would be equal to this side squared. The square root of anything squared is just 2r plus 2. So let's go ahead and do this. So 8r plus 1 times 8r plus 1, square root times the square root, that's simply going to be 8r plus 1. Now I'm going to have this 8r plus 1 multiplied by minus 1. And then I'm going to have this minus 1 multiplied by 8r minus plus 1. So what this is really going to be, that's 2 of those. So I'm going to have minus 2 times the square root of 8r plus 1. Lastly, I have a negative 1 times negative 1. It's going to be plus 1. Okay, so now let's do some simplifying on this side. I have 8r, and I have a plus 1, and a plus 1, minus 2 times 8r plus 1. Okay, let's go ahead and move these to the other side. And so what I'm going to do is I'm going to subtract 8r from both sides. So that's going to give me a negative 2 times 8r plus 1. And so if I subtract 8 from both sides, I get a negative 6r. And now this 2 is going to move to the other side. So I'm going to subtract 2 from both sides. And that'd be a negative 2 plus 2 is 0. So now I'm going to divide both sides by this negative 2. So if I divide this side by a negative 2 and this side by a negative 2, I get the square root of 8r plus 1 is equal to 3r. Now then, I have this radical isolated, so once again, I'm going to square both sides. And I have 8r plus 1 is equal to, now the 3 gets squared, so that's 9, and I get r squared. So the next step would be to set everything on this side equal to 0 and move everything over. So I've got 0 is equal to 9r squared minus 8r plus 1. Okay, so let's do AC middle on that. And I'm going to go ahead and do that by turning off the video for a second so that it's not quite so long. This is really taking some time. So anyway, here was my quadratic equation, and I did AC middle, and here's my factors. and so I solved it. So I got r is equal to -1/9 and r is equal to 1. Okay, so if you check both those, what you're going to find is this is a good solution. This is not. Okay, so let's save some time and just not do that, but you would check those. Okay, let's go to this other one. This is going to be a little more complicated. Okay, so I'm going to rewrite this. So what this is going to be is 33 all over 4. And that's going to be equal to 2. And now this is to the -1/2. The part in parentheses is to the -1/2 power. So I'm going to go ahead and put that down as a denominator and take the negative off of it. Plus 8. Now what I need to do is I need to get this bottom part that has a 1/2 on it. It needs to be a numerator. So it's going to have to go to the other side of the equation. But first I'm going to go ahead and do as much simplification as I can first. So this 8 over here, I'm going to subtract it from both sides. Now this is 33 over 4, and 8 is actually 32 over 4, right? So when I subtract the 8, I'm just going to go ahead and change it into a fraction. And that would give me 2 all over 2p plus 16 to the 1/2 power. So when I subtract, I'm going to have 1/4 is equal to 2 all over 2p plus 16 to the 1/2. Now, to get this 2p plus 16 to the 1/2 up to a numerator, I'm going to have to multiply both sides by 2p plus 16 to the 1/2, basically over 1, and I'll do the same thing to this side over here. So since I have this, well, let's just erase it. So this side would also have to multiply by 2p plus 16 to the 1/2. So what I would end up with when I do that is I'm going to end up with 2p plus 16 to the 1/2 power times this 1/4, so that's over 4. And the other side, this 2p plus 16 to the 1/2, and that 2p plus 16 to the 1/2 will cancel. That'll be over 2. All right? Or be 2. So now what I'm going to do is I'm going to multiply both sides by 4 to get this 4 to the other side. So I'm going to end up at 2p plus 16 to the 1/2 power is equal to 8. And now then I have the part with the rational exponent all isolated as a numerator. We're ready to do something to that. So what I'm going to do is I'm going to take it to get rid of the 1/2. I'm going to take this side and square it, which means I have to take the other side and square it also. So I'm going to have 2p plus 16 is equal to 64. I'm going to subtract 16. So I'm going to get 2p. If I subtract 16, I get 48. Now I'm going to divide both sides by 2. So I get p is 24. Okay, so that's my answer. And if we check that out, I guess I have enough room here. So actually, if you check it, it's going to work. So I'll let you do the check, but you're just going to put 24 in for p, and it's going to come out. So let's go to the next one. Okay, sketch the graph of each function. How much more of this we got left? Actually, that's the end of that page, so let's stop the video right there.